Before we start solving equations, remember that you can follow me on YouTube, SV Math Teach. Like and subscribe and help me out for these free videos. Now let's get started. Today we're going to work on the first topic in section 2, combining like terms. Now, combining like terms simply means that you have more than one of the same variable on the same side. And I have two examples to keep this brief. My two examples, the first one involves a fraction, the second one involves some decimals. You could of course do integers as well, but let's get started. What you should notice about combining like terms is that when I split a problem kind of into a left and right, the left is to the left of the equal sign, right is to the right, of course, and we could do the same thing here, right? Split it left and right. If you find yourself with the same variable on the same side, I should point out I'm recording outdoors. There's a lot of cars driving by and birds chirping in the barn next door, so forgive me for the background. But that doesn't change the fact that when I'm looking at variables that are on the same side, I'm looking at like the common m's or the common x's, depending on if you look at the left problem or the right. So we want to put those together and we want to combine them. So the first one involves, well, combining fractions, adding fractions. So I need to get some common denominators. So I've got 2/3 x and a 1/4 x, and I need to have probably 12 as my common denominator. So I'm going to multiply by a number that gives me 12 as a common denominator. So 4/4 in the first one and 3/3 in the second one. So I have 8/12 x plus 3/12 x. And I'm going to combine my numerators, 8 plus 3, so I have 11/12 x and I haven't really done anything with the right hand side yet, so 10 comes down. I'm going to finish that off in just a moment, but let's do the right hand side with the decimals. Concept is exactly the same. I have like terms. I have m and m. I'm going to put a 1 in front of this because anytime I have just a plain old variable like m, there's one of them. In this case it's -1. And I have -1 minus 0.3. So some of you like to do the add the opposite trick or keep change flip, whatever your teacher calls it. You end up with -1.3 m is 2.4. So in both of these statements, I've combined my like terms. Now all that's really left is to, well, isolate the variable. In the left-hand problem, I'm going to isolate the variable by multiplying by what's called a reciprocal. Instead of 11/12, I'm going to do 12/11. You can see that the reciprocal is just flip the fraction over, and I'll show you what's cool about that in just a moment. Switch colors to red, because for me, red indicates things I can cancel out. I can cancel out the 11s because there's one on top and one on the bottom, and I can cancel out the 12s. Again, one on top and one on bottom, and I have x equals, so here we go. 10 times 12 is 120 divided by 11, and in just a moment I'm going to convert that over into something other than this improper fraction. On the right hand side, I'm going to do just straight up division, -1.3 and -1.3, and once again I'll use the red pen. The -1.3's cancel out, and I'm left with m equals, and this is really just getting into straightforward solving equations, right? So combining like terms is not a big deal. You just combine the terms together using the coefficients. That's the number in front of the variable. So to finish this off, I'm going to go ahead and use the calculator tool. Let's go ahead and check this out. And on the left hand, 120 divided by 11 is going to be 10.909, so x is equal to 10.90, repeating, because there's a repeating pattern. And now I'll do the one on the right, 2.4 divided by, I don't need to type in the negative because I know it's negative, so m is, and I'm going to round this one because of the decimals, I'm going to say it's approximately -1.85, and that'll do the job. So that is how you combine like terms and how you solve an equation involving like terms.